So now boys, today we're going to be talking about work. Now, the formula for work is force times distance. Work is force times distance. And the units, where it says the SI unit, is joules. So you do 1 joule as your answer. Distance, the unit for example, is 1 meter. And for force, the units are newtons. Now, an example of work done is anything, say a ball, that has been given a force and it has also moved a distance. Okay? If this is an example of work done, now if the force is given but the ball, let's say, moves in the opposite direction. Now this is an example of negative work. Whereas the other one in the same direction is an example of positive work. Okay? Of course, if you have a ball and let's say there's a force but there's no distance, okay, then there's no work. Even though there's a force, there's no work. The same thing, if some ball is moving with a distance but there's no force, for example, how can there be no force? It could be moving at constant velocity. If it's constant velocity, there's no acceleration. And if there's no acceleration, then there's no force. Because remember, force equals mass times acceleration. This is a previous lesson. So these two examples have no work because this one has a force with no distance. This one has a distance but no force. There's one other example where you can have no work, and that's if you have a force and a distance, but they are in completely different directions. They are what's called perpendicular, 90 degrees. Perpendicular. Okay? You have a force and a distance, but they are at 90 degrees, perpendicular. They have no work still. So let's go through each of these examples and see if work is done. A man pushing a wall. Well, here's a man pushing a wall. There is a force, but the wall does not move, so there is no distance. Distance equals 0. So, in our example, if there is a force but no distance, no work. A worker holding a box and going upstairs. In this case, the worker has a force upwards, so he's going upstairs, and he's also moving upstairs, so there's a distance. A force and a distance in the same direction is positive work done. A car moving with constant velocity. Well, there's the car moving with a constant velocity. Let's say the velocity is staying at 20. It has a distance, but is there a force? You might think there is because it's moving, but remember, it's a constant velocity, meaning the acceleration is nothing. It's not accelerating. And if there's no acceleration, there's no force. So this car has no work done, because this is an example of this, where there's a distance but no force, no work. Final example, the road exerts a friction force on a speeding car skidding to a stop. Now in this case, the car is skidding to a stop. So it's moving with a distance, but it's slowing down. The acceleration is negative, slowing down. If there's an acceleration, there must be a force. And if there's a force and a distance, then there's work done. However, just note that the direction of the force in this case will be opposite the distance to slow it down. And when the two, force and distance, are in opposite directions, the work done is negative. A very good question now about how to solve a question with numbers on work done. A constant force of 200 newtons makes a work of 1,200 joules on an object. How far did the object move in the direction of the force? So here we are given 200 newtons, 1,200 joules, and the question is how far? For this we're going to need our triangle, our work done triangle. Now as you can see, for work done the units are joules, so joules must be work. For newtons we must be talking about force. And how far, the question is asking about distance. Okay, so we want to find distance. We cover up D on the triangle and we write down D equals W divided by F. W divided by F. Work divided by force. Now you just put in the numbers, 1200 joules divided by 200 newtons. This requires a bit of mental maths, but to make it easier for you, if you've got zeros, you can just cancel them out. 2 zeros here, 2 zeros here. 12 divided by 2, that's the same as 6. Units of distance, meters. There's your answer.